All right, M number 10. I can use and identify additive and multiplicative inverses and identities. So you need to know the difference between identities and inverses. Identities keep the matrix the same. Inverses do the opposite of it or turn it into the identity. So the additive identity is, what is the additive identity of this? Well, I need something so that this keeps its identity. Well, keeping your identity is not changing. So I want to add this to the additive identity, which would be all zeros that are the exact same size as this one, so that this can keep its identity. That's the way it can do that, because then the answer would stay the same. Multiplicative inverse, this is where a calculator definitely comes in, because what you're going to want to do with this is you're going to want to type this in as matrix A on your calculator. So get matrix A typed in a 2 by 2 matrix, call it that, and then find the negative 1 power button on your calculator. So simply what you do is you go into your matrix and you type it in somewhere. You know, you go say, hey, I want a 2 by 2 matrix, and you just type it in. And so in this case, it would be 2, 4, so I just go 2, 4, and then I go 3, -2, get it all typed in. Go back to your main screen and just go second matrix, select the matrix that you wanted, and then just hit to the -1 power button, and then boom, it calculates it for you. A good tip for you to remember is worth going math, enter, enter, because math frac will turn it into fractions. Sometimes those are nice if your decimals run off the page. And so then we have the multiplicative inverse. Now we're going to use that multiplicative inverse answer in the next problem, because if I take and I have an A matrix that I don't know, A is being multiplied by B and it's getting a C matrix over here, well then what I want to do is I want to multiply by A inverse right here, because A inverse cancels A. And then right here I would put A inverse, and then B would equal A inverse times matrix C, and I would have my solution. So we talked about that in class, that this is the property that we're using. If I had matrix A here, then I would do matrix A inverse. So A and A inverse cancel each other out on this side, therefore you have to do it in the front. You have to do it in the front. So A inverse has to be multiplied by C right there. And so then when you work that out, here's what the solutions would look like. You would have the fractions that we talked about would go right in that little gap, because then A inverse times C, which is another thing you could do on your calculator, and then you can get the final missing matrix, which I have showing right here. So that's the process that you need to remember, is right there. And then you just type it in your calculator and use it. Now, one word of caution is that there is, you're looking for, so let's just keep going with this. Additive inverse would be all the opposites of this. So if I add these to its opposites, then it would turn into the identity, which is zeros. So I'm trying to look for the matrix that would cancel out all of these. Well, that's pretty easy, because it would be canceled out by all of their opposites. Then the multiplicative identity of this, I want to be able to turn it into ones and zeros across the main diagonal, because the multiplicative identity is 1, 0, 0, 1 for a square matrix, or it would be 1, 0, 0, 0, 1, 0, 0, 0, 1 for a 3 by 3 matrix. So it depends, but it has to be a square matrix, and so this one's not square, so there's nothing that I could multiply by to turn it into that, so it doesn't work. Essentially there's no inverse for it, so it doesn't work. And then find the missing matrix. This is an additive thing, so then that would obviously be, I want to take 2x and add it to something so it turns into 3. Well, that's doing something like this. We'll get rid of the 2x, so minus 2x and then plus 3 would be your first corner. I need a little bit of room in here, but I ran out. But if I took 2x and then negative 2x and 3, those would cancel. I'll be left with 3. So you have to think about what I would add it to make that solution matrix.